Welcome back, everyone. Your instructor, Dr. Rodriguez, here with another application example. This time we're looking at, actually, word of caution, never connect your control device or PLC to a big load. You're going to fry that. We've been saying that, and we'll continue to preach it. It's such an important concept. And let me close this file so that I can bring up the appropriate file for this. And this is the forward and reverse example. This is what we're looking at. In this particular example, the diagram shows a delay. We're going to leave the delays for later. So ignore the delays on this one, TR, these TRs. Ignore the delays. All right, so ignore the delays, TR2, TR1, and just focus on the rest. So we have a stop, forward, reverse, a motor, a seal for the motor on both, and then of course we got the timer instructions, which we're going to ignore at this time because I have another example where I can show you timer applications. But I wanted just to concentrate on this application, which is called forward and reverse operation. This is the case for a machine that either has a single electrical motor that's able to rotate in both directions, or two motors, one that will move the machine in one direction and the other motor that will move the machine in the other direction. So I have the design already here, and this system utilizes, let's see, 7 instructions, 3 physical input, which is the forward, the reverse, and of course the stop, which can be repeated, right? And then we have the forward output and the reverse output. Additionally, we have a couple of internal instructions, and those are a examine if open or normally closed, reverse output interlock, and then forward output interlock, and then of course the seal for the circuit. So if you recognize the upper part of this circuit, of this ladder diagram, is basically is a start-stop system, right? That's what it is. So we have replicated the start-stop system twice, and we've added a safety feature to it. Basically what you want is anytime the forward output is running, you don't want this thing to run, right? That'll be equivalent to you going in forward in your car and then suddenly put in reverse. Guess what's going to happen? You're going to turn around, you're going to kill yourself, and you don't want to do that. So you put the brakes and then you go in reverse. This is the same concept right here. Likewise, when I'm going in reverse, I want the reverse operation to go forward, but I don't want the forward reversal to happen at that time. In other words, you got to stop one to do the other. And that's what this circuit is all about. It's about forward and reverse with an interlock system that prohibits one operation to happen while the other one is happening. They both have to be independently actuated, or the system has to be stopped before you actually can run this. So once again, there is the file verify and there's the project verify. You'll want to run that to make sure that there's no errors, such as this one says verify has completed, no errors. That's the way to diagnose these programs. I'm going to see if I can zoom this one so you can see the end of it. All right, here's our program. And what I'm going to do is we're going to run this one. Notice that my input addresses are the red push button, which I already have here, the green put button. In addition, I have an input 4, right? Actually, let me back out. My input 0 is my push button, which serves for both rungs, right? And then my forward is input 3, which is this switch is a 2-position switch, and it's connected to terminals input 3 and input 4. So when it's selected in input 3, it's going to go forward. When it's selected in input port 4, it's going to go in reverse. But it cannot go in both directions. So let's go ahead and download it. All right, and as we download it, just wait for a little second. We should be ready to run. Once again, I'm running my actual hardware. You may have to run your simulation software. And I'm going to go forward by pressing this 2 position, which has input 3 forward and input 4 reverse. So there's the forward. Now, if I actuate this to enable the input 4, nothing happens, right? which is exactly what you're expecting. This system will be going on until it's stopped. So now it's stopped. I'm gonna energize the reverse operation. There's reverse, and at that time nothing else should matter, right? Because that's the way you want it. You don't want this to be running back and forth without any precautions. So that means I have to stop it before I can do anything else. So that is the forward and reverse operation as it is established on many of the traditional systems controls that you find where ladder logic and PLC applications are the solution for that. So once again, this is the forward and reverse control, and you're going to have both a PDF file with this, and you will also have the ladder program, which I'm going to provide to you so that you can do whatever you need to do with that ladder logic program. All right. Once again, review, and if you want to mess up with this, you can also modify your project so that you can do whatever you want. For instance, just for the heck, I want to be able to add a line here to this program, and the line is going to be here. And what I want to do is I'm going to use a line that will energize a lamp while the system is de-energized. So I'm going to use that for that input 3, or output 3 I should say. So I'm modifying this project from its original. I'm going to use the input table, and because I know that my red lamp is connected to input 3, I'm going to use that address, hold it down, bring it over, and I have modified. Now what do I want here? Well, I want this to be on as nothing is happening. So I can use any of the 2 output addresses to energize this. All right, so my options are, let's just check it out. What happens if we add this address to this one right here? Let's go ahead and download it, okay? So you can see what's happening here. No errors. I'm going to proceed to do that. And so as the system goes online, one light is already on, right? Oops, do you see the mistake that I made? I'm addressing this output with an input address, right? And those are things that the system will not catch up, right? I have added an input address to an output energize instruction, and that's the reason why it's not going to work. So let's back out, and what I want to do is I want to be able to address that properly using the output table, and what I wanted there is actually output 3. All right, so output 3 is what I want, and that output 3 I can edit it, and this is going to be the red pilot light. Okay, so there's our system. I'm going to go ahead and download it, and everything should work as expected this time. These examples are tremendous because that's what you'll find in industry, all right? So as expected, our system is de-energized, which means this red light is on, indicate the system is de-energized. As I start the system forward, I expect that light will go out. All right, and the system is going forward. Now, what are we missing here? Well, I'm going to stop the system. The light of indicating the system off will be energized once again. But what happened when I energize the reverse position? The system is still on. So what will you do? All right, this is a good example. So we're going to modify the circuit. I'm going to stop it first, and we're going to add one more instruction. All right, and this goes back to our digital logic. I want a branch, right, that either this pilot light or this output energize will disable this light, or this output energize will disable the light. And so I'm going to take away the address of this one. All right, and now I have really a system going on. And you recognize here, what do we have here? This is an OR instruction, right? What the system's saying is, if this output is energized, I want the light to be de-energized. Okay? Or if this output is energized, I want also the light to be de-energized. All right, let's see if it works. If not, we're going to come back to the drawing board and we're going to modify that, okay? We're just kind of troubleshooting here the exercise, which is part of the skills that you're supposed to get. There's one other possibility, actually there's more than one, that we could do with this design here. So there's everything, right? And we probably have to do something better than what we have here. So let's go forward. Oh, sorry. System is going on. Now the light's still going on here, right? And we don't want that. Do we? We don't want that. So something needs to change. Let's stop the system. I'm going to go in reverse, which still keeps the off system light energized, but I don't want that, right? So we need to modify this up, and essentially what we need to do is exactly what we have here. Exactly what we have here. So we need this these two pilot lights to be in sync with our system. So how do we fix a situation like the one we had? Well, it's already been fixed right here. Notice what we have here. We've added a couple of unique instructions, and you probably recognize here that we have, this will be an AND, right? That's an AND right there, and this is an AND. So we got two NANDs ordered. And again, this is probably away from the original design, which it is, but we're just in the process of enhancing what we're doing. And what we just done is we've added a feature that allows us to see when the system is off and when the system is going forward and when the system is going reverse. So let's give it a shot. So okay, so that system is off. System is going forward, right? The red pilot light should be off. Nothing else should happen until I stop. Now I want the system to go in reverse, and system is reversed. Nothing else happened, right? Until I stop it. At that time, the pilot light is on. So you may want to explore this design and do whatever you need to do. Here it is one more time. Let's just give it a shot. System's off. System is energized. Oops. Oops, I need to stop it. Yeah, there we go. So reverse. Nothing happened. I have to stop it. Forward. Nothing happened. I have to stop it. And then system's off. So that's our design. And we're going to stop here because our video is getting pretty big. But nice design nonetheless. And the idea here is to enable you to become a programmer. So you have to mess up with this design, test out your ideas, and then go from there. This is your instructor, Dr. Rodriguez, with the principles of ladder logic programming. This is our example number 3, I think. And I'm going to save a modified version of this. We'll see you in our next video in just a little bit.